Good evening.
Good evening. Good evening, everyone. Hope I am audible.
Yes, yes.
Yes.
Yes, you are
A
audible.
very good, yes. A very good evening, everyone. Hello and welcome to this 5 days online workshop and technical quiz on Industrial Process Safety Management PSM 2021. Now, I would request all other participants to kindly mute their audio. I would request all other participants to kindly mute their audio. So welcome to this PSM 2021 organized by Department of Chemical Engineering, Haldia Institute of Technology in collaboration with Internal Quality Assurance Cell, IQAC, HIT, and Students Chapter, HRC, IIChE, Indian Institute of Chemical Engineers, where we all are going to welcome esteemed dignitaries from notable industrial and academic domain to talk about their experiences. So before starting today's session, I have announcement for our participants. So before starting today's program, I would like to draw your attention towards an information. Please note it that tomorrow, that is on the 5th day of this online workshop, tomorrow, that is on the last day of this workshop, as it was pre-scheduled that there will be a quiz, and quiz link will be shared at the beginning of the program, that is at 7 p.m. sharp. That is tomorrow. The quiz will be held at 7 p.m. sharp. That is at the beginning of the technical schedule. Quiz will take place and the link will be shared here in the chat box. And you have to submit the response within 7:20. Again, I would repeat, that is on 5th day, that is tomorrow, that is the last day of our workshop. Quiz link will be shared at 7 p.m. sharp, and all of the participants will have to submit their response within 7:20. Now let's come back to our today's technical session. So welcome to this 4th day of online workshop. Now, as new technologies are developed, industry processes become more complicated. The processes require to involve lots of factors which were not used before in order to produce perfect products. As a result, people receive the benefits from high quality with low price of products, and companies also flourish their business and invest more capital to develop their technologies to make better products with low cost. However, these changes, ranging from simple to complicated, are accompanied by risk of process failures as well. The risk not only affect their business, but also can be connected with safety of the workers and the general public. So to empower our students with sound concept in chemical engineering, who can excel as team member or as a leader in the field of research, entrepreneurship, industry, and management, we have put our step forward to give them the proper exposure in this field, which will definitely help them in future. So today we have joining with us Mr. Sanjeev Kumar Jana, Assistant General Manager, HAC, Indian Carbon Limited, Kolkata. He is Six Sigma Green Belt certified and an enterprising professional with total 22 years working experience. Among 16 years of rich and extensive experience in HSE management and 6 years in chemical plant process operation and utility department. He is skilled in developing safe environment and creating zero accident and occurrence culture by implementing applicable HSE policies. He is currently working as a management representative of EHS system of ISO 14001-2015 and ISO 45001-2018 and passed several lead auditor courses. He has insightful understanding of process hazard analysis, hazard effect analysis, tabletop drill exercise. He has also gained extensive understanding of 12 pillars method of Tata safety system. He often played key role in identifying the training needs for all permanent and contractual employee regarding safety, occupational health, and firefighting. He ensured strict compliance as per Indian statutory obligations, factory and environment, applicable to manufacturing, chemical and engineering plant operation. Overall, he has core competencies in HSE management, SOP formulation and implementation, crisis and disaster management, emergency support, energy conservation, reporting and documentation, compliance audit, system implementation, hazard analysis, team management, and leadership. So myself, Aditi Sinha, Assistant Professor of Department of Chemical Engineering, HIT, on behalf of whole chemical engineering fraternity, would like to extend a very warm welcome to you, sir. It would be really an honor if you kindly share your valuable experience with our participants. Now the session is all yours.
Thank you, madam. I am very grateful to you and full organization team for participating in this program. Actually, I am learning from you that it is a very good. It is I often seen that the many institute they have many workshops they have done, but there I have seen that there is a gap between the industry and also the institute. They given only they given the theoretical class and also practicals, and they have made different workshop, but 80% case I have seen that no such interaction with the industry have not done. But I have seen earlier also this type of workshop I have attended earlier also. So it is very good and it is very helpful for the students. They have taken classes 4 years engineering courses, but they have not directly get a chance to interact with the industry people more. Actually, we have a vast knowledge about chemical industries, different type of industry. I have I work different type of industry in chemical, cement, and asbestos. Also now I am a chemical industry. So what happened when the students are coming after passing 4 years? They have no such knowledges how they starting period. It is very problem for the engineering students, because they have not a such type of industry experience in practically or so this type of seminar or workshop, it will help you for getting a bridges between the your studies, regular day by day studies with the industry experience, and that will be very much helpful in your career. So my subject is HIRA, hazard identification and risk assessment of a cement industry. Actually, HIRA, hazard identification and risk assessment, it is a heart of a safety system, process safety management system. There are different systems are there, safety systems there. There safety audit, safety observation system, identification of accident, and process safety management. You go there. Their safety trainings are there, audit, identification of accident and incident investigation, safety observation. But most of them, uh, uh, but HIRA it is called the safety, health and environment system. This HIRA, hazard identification and risk assessment, is the heart or core of this system, because different types of industry, it is chemical or chemicals, cement and other different industries, there is a different process are there. Because first, if you have to learn about the process very well, then the HIRA will be defined for each the process, because there are different type of process, and different type of process there you got the different type of hazards, and ultimate risks will be different, and that will be then you can identify properly what is the this process, this type of process, which type of hazard are there, and then you have to calculate the risk calculation. Then we go for the how critical that is. And actually earlier, what is the earlier safety system there, what happened, any accident happened, then management, top management come to that, why it is happened, and why they are mainly fault finding. Earlier there is a system of fault finding, not the fact finding. What is the fault finding and fact finding system in safety? uh, Fault finding means earlier any accident happened, top management blame any person or any machine or any person, they blame the person, and then sorting out that person or any that person. Earlier it is a blaming game, or uh, original root cause, what is the root cause of the accident, that not identified. So what happened, repeatedly the same type of accident or many accident happened, but later on very big industries or good industries, they actually identify what is the root cause of the accident, and then go for but again we told that there in safety system, lead indicator and lagging indicator is there. What is leading indicator and what is lagging indicator? Because it is very much required to understand before the HIRA, what is leading indicator and what is lagging indicator. Lagging indicator, what is earlier the process, any accident happened, then fault finding, what happened and what to do immediately, and correction or corrective action taken after the accident. That is, say for any investigation, accident investigation, this type of process is a lagging indicator, because after and also last 3-4 years accident statistics you got, and then you take action accordingly. But what is the leading indicator? Leading indicator like HIRA, JSA. HIRA means hazard identification risk assessment. JSA job safety analysis or job hazard analysis, or hazard study, and also different type of accident, and all the this type of preventive action taken that will reveal that no accident happen further. And one is the like a leading indicator, most leading indicator is near miss incident, root cause analysis and corrective action, identification of near miss case. So one of the most leading indicator is HIRA, hazard identification risk assessment, and one of the most valuable safety system is HIRA. But why I choose cement industry? You know that chemical, from you taken the BTech from chemical, you have a scope in chemical industry, cement industry, and some sort of pharmaceutical industry. You got, and so now I come to the presentation. One minute. Madam, can you see my presentation?
Yes, it is visible.
Okay. Now come to the hazard identification and risk assessment, or HIRA, of a cement plant. Actually, first I identify the cement industry, the process. Then we go for the another industry, chemical industry and pharma industry. Basic part is the same, but as per the process, it may some variation with the HIRA. And First, how the process to manage the hazard. Every in the cement industry, there you can see the storage. There different hazards are there. Mainly fire hazards for the storing of the raw materials, and then it comes to the storing. Then there are different processes are there. Reclaimer are there. Then it goes to the coal bean. Then it goes to the coal mill, and then after the different processes are there. Kiln are there, high temperature kiln are there, ball mill and vertical mill, different mills are there, and then come to the packing after the production done. Then come to the packing area, packing, then dispersed to the by the train or uh, by the truck. There are different processes are there. First, we have to identify the hazard. What can cause the injury or illness? Uh, any what is the first we have to identify the hazard. What is hazard? Hazard actually that is the cause, and the risk is the this result. So hazard and risk, that is the main uh, uh, things in the HIRA. So we have to identify the hazard, identify more numbers of hazards, and uh, then identify the hazard. Then we have to assess the risks, and after that we have to control the risks. Assess the risks. First, identify hazard, different type of hazard. Say for one example of a hazard. Uh, in industry, there we are using different type of oils, uh, furnace oils, different types of diesel oil, different of oils we are using. When we are transporting transfer this oil from one place to another place, there any spillage, there is a chances of slippery of the floor. That is the spillage of the oil. It is a hazard. And what is the cause? One may fallen on ground and hurt his body, or any incident may happen. That is a risk. So hazard, what is hazard? Slippery of the floor, so spillage of oil, it is hazard. And risk, the risk is the any severe accident is fallen on the ground, any person, that is a risk. Then we have to take the control risk. What to be do for controlling the risk to this fallen in the ground? How we can prevent it? There is a 5 steps are there. 5 controlling steps are there for eliminate this hazard. I go later on. 5 steps control measures are there. One is elimination process, uh, engineering process, elimination process, substitution method. Then we are go for the engineering control. Fourth is the administrative control, and PP is personal protective equipment is the last line of defense. It is called the fifth or last control measures. Then process to manage the hazard, assess the risk. How likely is the incident going to occur which will result in the injury or illness? Risk. How likely? It is a severe case, or it is a little bit accident, it may happen. It is a minor, or it is a medium, or it is a severe. How likely is the incident going to occur which will result in the injury or illness? So second part of the HIRA is assess the risks. Assess the risks. Second is the assess, how critical, what is the severity of the risk. Then our third process to manage the hazard. Okay, that is control the risk. There is a 5 steps method. I go for the detailing of the each process. First is identifying the hazards. First, describe the detailing of what is hazard. A hazard is defined as a condition with the potential of the causing injury to personnel, damage to property, loss of material, of the ability to perform a prescribed function. Actually, it is a condition of or potential of the causing injury in the personnel, damage to the property. And a risk is defined as the risk is the change of something happening that will happen, impact, objective or targets. It is measured in terms of likelihood, consequences, and may arise from the event, action, from the lack of condition. So likelihood and consequences, how severe it is and what frequency it is happened. Ultimately, these two we calculating the risk matrix, multiplying with this likelihood and consequences, the risk matrix or risk calculation is done. How the hazard, how critical it is. Then we controlling risk is defined as the action or measures taken to avoid or reduce the exposure to a hazard and such that the potential or negative consequences are minimized. To minimize or eliminate this acceptable level, we taken to the controlling risks. Controlling 5 controlling measures are there. Hazard overview. Hazard are grouped into 4 common sources: people, environment, equipment, and materials. We are coming this hazard through the sources is people, mainly from the people, environment, equipment, and materials. Okay, people. If we go for the fishbone diagram, main hazard people. By people, posture or repetition, or in body posture of the people, it may affect this type of hazard. Lifting tools, pushing, pulling, slips, trips, and falls. For the equipment, if it is a mobile or portable equipment or fixed or falling or flying objects, if it's a grinding wheel, there it is chances if we not wearing there is a uh, falling or flying object to the eye. Environment, temperature, heat, cold, temperature, noise, vibration, and materials, chemical, radiation, and electricity. This is the main sources of hazard. Ultimate, this hazard happened. Hazard as the demanding energy sources, gravitational, muscular, strain, and psychological, and how it affects this hazard is a our damaging the energy sources. Okay, then and for the environment, it is different type of environment. It may affects in the hazards: thermal, atmosphere, biological, and dust. Thermal, if it is a cold, you have seen that different in the industry people doing jobs in the plants, there is a very confined space is there, and there is no ventilation system is very poor. Then there in hot season, that is a they are very the sweating will be there, and so people who are doing work in the working place, they that may affect ultimate in body and mind, and ultimate it this hazard go as a severe risk, and ultimate it may cause a accident. Exposure to the poor air quality, oxygen level, conference, if in the doing in shutdown job, they are you see different vessels are cleaning or emptied. That time the oxygen level is very less, or properly not ventilated, or force draft fan is not used for that. There is a chances of if oxygen level is very low, there is a chances of accident. Ultimate actually hazard happen. This hazard ultimate goes to the uh, critical risk, and ultimate it affects as a accident. And damage from the contact with the biological organism, and damage from the exposure to dust. If in our industry it is a coal dust is there, our industry India Carbon Limited, they are actually raw material come RPC, raw pet coke, and then when we go uh, calcined pet coke, it is a very dusty format, dust for. If we inhaling the dust, the workmen or the staffs, dust inhaling, and there is a chances of pneumocomoniasis and different silicon also there, silicosis also chances of there. So these affect ultimate affect our body, and ultimate this is a severe risk. It may severe risk. And in equipment, hazardous demanding energy sources, fixed plant and mobile, different type of fixed mobile gravitational potential, and damage causes by contact with the object in the motion, object in the motion, collision with the vehicles, or where the forklift, truck. In cement industry, you can see there many trucks are coming inside with the raw materials, and also the product after making the product from packing plant. Then the every day around 150 to 200 minimum trucks in out. There is a chances of collision, and vehicles also they are using forklift and different type of crane, hydra. There is a chances of collision with the vehicles. That is it. And equipment failure and damage causes the contact with the stored energy. Different pressure type of systems is there. Material damage caused by the chemical in inhalation, ingestion, swelling. There is a it is in chemical, and also the cement plant. There is a effect in the this chemical effect, material effect in the body, and this ultimate effective on the hazard. And when we calculating the risks, it may a critical hazards may happen. And damage and presence of hazard, these four sources are there, and you can see this presence. It may be visible, something we can see visible, some can see hidden, or some is developing. And presence of hazard, visible hazard, hidden hazard, and developing hazard. What is the this this visible hazards? Those readily seen hazard which can see directly, heard, smell, tasted. That is moving machine parts, open edges, vehicles. That is a visible. We can see some hidden hazard, dust that cannot be seen properly. But this dust, very fine dust, and it ultimately affects in our body. Very micron size are there, and ultimate we that effect in body we cannot see or readily sensed without promoting the more detailed search. Ergonomic stressors, ergonomical, the body postures where we doing the jobs, we cannot sing properly or identifying. And developing hazard, these get odds over time may not be detected without measurement. Integrity of the plant, corrosion, design failure, more that ultimate the developing hazards. You can see in the plant there are different of hazard. Here in clean area you can see the thermal hazard, magnetic hazard, gravitation, radiation, vibration, different type of hazards in all over the plant. In cement plant, different hazards are this type of all hazards are there in different places or different locations. Common also chemical, here I can see here some chemical industry. Chemical industry, cement also, it is a chemical industry. Their quarry or blending is there. What is the common hazards you can see here, and what is the process and ultimate, uh, this this is a ultimate blending process, processing, main processing, then grinding and dispatch. Different hazards are there. Here you can see one hazard identification. Here you can what type of hazards are there. There bamboo, here no, uh, you can see here bamboo is using in the this place. It may fallen or it may broken. That is a hazard. So identify the hazard. We can find additional information hazard from the examination. There, when we are doing this job, there are no toolbox meeting, or we have to identify the hazards first. Then we come for the risks. Uh, Risks. Then what is the assess the risks? Assess the risks. We have to give the priority action. Risk assessment is a way of understanding the full potential of any hazard or incident. By understanding the risks, first we have to priority the action, how critical it is, how it is a critical hazard, critical risk, or it is a moderate, or it is a negligible risk. Okay, for the proactive approach of the city, it is the proactive. No accident happened, but earlier then, to assess the risk, we identify the hazards first. Assessing risks, consequences. Consequences in time of occupational health safety is the degree of harm that could be caused to the people exposed to the hazard and potential severity of the injuries or ill health, and or the number of the people who caused to potentially affected, and likelihood. Consequences and likelihood, how the probability and how critical or degree of harm. For assessing the risks, we have to two steps: consequences and likelihood. First, we clearly identify the situation, hazard, or incident scenario. In every industry, department wise, we have to first identify all the hazards, then hazard uh, by uh, daily job or daily routine job or non-routine job. Then identify all numbers of hazards. So in any industry, any department, the departmental head's duty with the subordinate, and also the is all the workmen or engineers and ground people. They are focused on the more to the ground people, those who are directly involved in the job, directly, manually, or physically doing the job. Because uh, accident happen uh, from that workman or the staffs, because they are associated with the machines or plant area, more plant area. So they can give clear picture of this, identify the hazards or the situation they faced day by day. In shifting duty, they face different problems or hazards. They have to give, we have to take hazard from them and then decide on the worst credible consequences and determine the probability, likelihood, or the situation or event causing in the consequences to be identified, where the consequences and likelihood interact to reach the value. Okay, so there we have to identify the hazard, then we how much severe it is, and what uh, uh, how many frequency how many frequencies the accident happened. There is a calculation of these consequences with the likelihood. Assessing risk, identify the hazard first, then hazard through the equipment. Heavy, here you can see a heavy mobile equipment, a bulldozer. And what is the incident? Incident scenario is spotter standing in the blind spot of a bulldozer, resulting the bulldozer reversing when reversing over the spotter, because there it is not seen by the driver, and ultimate this spotter is trapped or this type of accident. So assessing the risks, they are either blind, the mirror is not working, or the spotter who is the standing position is not right. That is the assessing the risks, why it is happened, and there we have to calculate the criticality of the hazard. Here you can see the consequence, risk classification matrix. We have to give the number system. Earlier I have seen when we give the risk clarification, there the significant, minor, moderate, major, and very dramatic. That is any incident, say for insignificant, minor incident, moderate, major, and dramatic. For that, a minor injury or first aid case injury happened, very insignificant, and medical treatment case, MTI, it is called as MTI, lost time injury. Lost time injury means 48 hours one person is injured but not returned back. Permanent disablement, okay, and fatality, it is fatality. Okay, it is safety, environment, cost effective, operation, legal, and involvement. There, if a cost involvement, if it is less than 10,000, you give the insignificant. Less than 1 lakh, okay. Then minor, this type of image for safety you can see, environment, cost effective, operation, and then consequence risk clarification matrix step, identify the potential consequences, incident, spotter crust resulting the multiple serious injury, fatality to one. Okay, and second, likelihood or risk clarification matrix. What is that? Likelihood, it is the frequency. Likelihood means it is the frequency, how frequency the hazard happened. Okay, this incident happened. Almost certain, it is give the event exposure daily. It is monthly, annually. Very unlikely event exposure one time in a 10 years. If it is very rare, it is one time in a 100 years. But it is for a cement industry, not for the only this clarification. You have to identify, uh, it may be even for daily or monthly, annually. You have to judge as per your
industry specific study. Okay, how many incident happened every month? It is industry to industry, it will vary. In cement industry, if it is a grinding unit, it may less. If it is a integrated cement industry, there chances of incident more. So you have to judge these number, how many you have to taken. That will be as per your company, as per your plant specific, and also judged by the senior team members. Likelihood risk clarification of the matrix. Identify the likelihood that the incident would occur resulting in the consequences. Likelihood occasional, likelihood C. Okay, it will be, if it is very occasional, it will come so under the C. You can see here risk clarification matrix. What is risk clarification matrix? You can see earlier, you can see that likelihood, what is the frequency of the incident happened. If it is a very likely, okay, likely, it will comes, you go to the directly this line. Okay, if this incident happened, it is a moderate type of incident, then likely this line and moderate this line, it will cut here. Likely this row and moderate this row. It will ultimate, moderate means this is 3 and likely means this is B. So multiple, actually, if it is also calculating 1 2 3 4 5, that ultimate it goes to this line, this likely, and it is moderate. So it is the high significance area. Say for any accident, one case study we have taken, in a cement industry, there is different height job is there, and in the shutdown time, it is seen that when the height job is done, every 2 hours there is a major incident happened. Major means this region. Major means very critically injured. But every 2 years, so it will be likely every 2 years, okay, or it may comes in the occasional. Okay, this occasionally to every years or every 2 years, we may call it is a occasional case. Occasional state here and major incident. So it comes in the this region 8. It is a high risk or critical risk zone. Okay, here you can see the red zone is the critical zone. So this criticality risk, if the risk is come in this area, this red zone, that is a critical risk zone. So management have to stop the job immediately and take action immediately. And if it is in the yellow zone, it is a moderate risk. Moderate risk, here you have to take few days. After that, you can take action immediately. Okay, if it is a green zone, it may you can very normal case, you can take some action further. Okay, so if a major, here is, you can see dramatic, major, moderate, minor, and insignificant. in height work, one person doing job, and he fallen down, and it is seen that every 1 year or 2 years shutdown job it is happened. So every year it happens, so it will comes under likely or occasionally. Okay. Or likely or almost certain. Okay. And if this person it is not high position and it fallen down, it may chance of major or dramatic accident, or moderate. If it is moderate and we go to the occasional, it will come under this 13 or medium range. Okay, that is a risk classification matrix. One is likelihood or frequency, and it is a and consequences, or it is called the severity. You see here the very occasional any accident, event to exposure annually. Okay, and earlier I have seen it will be decided by this likelihood. This will be decided by the industry experienced person. Okay, if a industry cement industry different grinding unit, their accident lower than the integrated plant, so it may changes this likelihood. You have to decide how many you will take it events exposure to the annually or quarter 2 years, it will you have to judge. Okay, and if it is a occasional event exposure annually, it straight goes to this position, and it is a fatal incident, so it is dramatic, so it goes to this area. It is a high or critical risk zone. Okay, so consequences and likelihood indicates the risk value is in these four. So it is a high, so requiring the immediate action to reduce the risk. You have to control. You have to control the risk. There is a 5 methods are there. What is the 5 methods? First, you have to try the eliminating the process or substitute. Second is substitution of the process. Third is the uh, third is the engineering control. Fourth is the administrative control, and fifth is the PPE or personal protective equipment. We have to take control measures. Then again, we have to calculate after giving the control measures for a certain interval of time. We have to take calculating again this risk classification matrix, because after giving it, we have given the control measures, but after that we have to again calculation this method. Is the risk is this priority critical risks come under the minor injury clarification, that we have to again we have to calculate. Controlling risks. Controlling risks, the actions or measures taken to the avoid to or reduce the exposure. What I have earlier say, you can say elimination process. It is the hierarchy of the hazard control. Eliminate, redesigning the task to the eliminate of a hazard, substitute, engineering or isolation, and administration or training, then PP. Okay, that is the hazard control methods. Hierarchy of the controlling. If you take the elimination, here you can see the most effective is the first two part. Here 100% effective if you take the elimination substitution 75% effective, and that's it. And effectiveness of the control, control, elimination, substitution, engineering, administration, and training. How effect, consequence, and ultimate the remove and redesign the process of the plant so the hazard not exist. Okay, and substitution hazard. One simple example. Earlier, their DG sets are very high noise emitting DG are there. But nowadays, elimination process what happened? That old DG not using, and we are now all eliminate that uh, hazard. What hazard? So we have taken uh, substitution method or engineering control method or engineering control measures by the noise enclosure. We have taken new type of DG generator set. What new type of generator set there that is actually full covered and noise is not emitting outside. That is also engineering or substitution methods. Now I come to a example. One minute. I have given you some example of hello. You can see this slide. Hello.
Yes.
Okay. It is a cement plant. One cement plants. Here is there. How we can make a Hira? How we make a Hira chart, Hira matrix. First, it is a electrical department's Hira process. Identical risk assessment or control measures worksheet, and there right side you have to make if it is for the ISO guideline, ISO OSAS or ISO 45001, IIChE management system 4.3 for it is which clause. If it is 4.3, that is written in right side. Date, when it is made and when it is reviewed. Here prepared by the who it is prepared. Any engineer, normally it will be engineer, manager, it will engineer by that. And next it will be reviewed by HOD or his section head. Okay, it is prepared by. Then hazard identification. We have to identify the hazard. Different type of, you have to serial number 1 to 3 activities. It is for the electrical job. We have to first take all the hazard. It may be enormous number of hazard you have to take, and different hazards, likely operation and maintenance (CTPT) and cleaning and oil level checking. Okay, it may be a routine job or non-routine job. All jobs to be taken activity. First, we take the cleaning of oil and level checking. It is the activity of job. Then occupational health and safety hazard. What hazards are there? Exposure to the live or electricity, electrically charged wire. Okay, it is a hazard. Emission of dust and fall from the height. These three main three hazards from that. But what is the risk for that? If electrically charged were there, there is a chances of electrical shock and elimination of dust, suffocation or breathing irritation problem, fall from height, body injured. Then who get affected or exposed? Electrician, worker, there may be chances of accident, because normally senior person is not there. Mainly those who are doing job in the ground area, electrician or workers. And what types of activity, it is a regular job or non-regular job are. Then we have to take the existing control. What we have take, they are defined the being the followed. OCP, they are actually one control point in the different industry, different type of OCP, one point lesion, or SOP. They have given in SOP what to be do. Okay, and there what existing control measures are there. One here, the well top up. When we top up the exposure the mineral oil mist, irrigation problem, electrician and worker, and existing. What happened if spillage of oil? We wipe up with the cloth. Then we go for the any gap is there, water facilities in the vicinity for the rising eye and skin in the case of contact. Okay, then after education of the risk control measures, then we go for the residue risk assessment. After we go for the elimination existing control measures, then we go for the residue risk assessment. Actually, it is calculated risks, how likely or likelihood and how severe it is, and some exposure. Sometimes it may cause exposure. So in the chemical plant, it another point is exposure. Normally, frequency, severity, or likelihood and consequences. There another point is coming the exposure, where the if the chemical there is the exposure is there, we have to taken care for that. Ultimate, we have to calculating this score 1 2 3 4 5, which number is coming, then we calculating it, and we take it in the risk matrix, where it is actually it is a trivial, or it is a tolerable, or it is a moderate. Okay, if it is a very trivial or it is very critical, then we have to take immediate action. It is significance risk. No. If it is significance or critical risk, then we have to take additional control measures immediately. Okay, it is one example. Then you go for shifting of CT and PT, current transformer and potential transformer. there is a chances of it is the then it is here it is the hazard is fall over the body and erection of the direction and indirect electric shock. That is all the hazards is there. Accordingly, the risk is there fall over the body may injury, electric shock, and fall over the body injury, eye irritation. If it is checking of insulator for the breakage and leaks. So exposure to the material oil mist, eye irritation, it is the risk, and electrician, it is a routine job, wipe with cloth, then it is a gap, then we calculating it, it is in the tolerable risk. If it is a very critical risk, we have to taken care uh, immediately, and top management with a management meeting will be done immediately as per safety point of view, as per factory act rules, and also in the OSAS. Earlier it is ISO 18001 occupational health safety assessment series, and now it is ISO 45001. There tell that every critical risk should be taken care immediately, or management committee meeting will be done, and immediately stop the job and take or taken to the control measures to be taken. After that, again we have to take calculating of this risk assessment or risk assessment matrix. This critical risks or this critical risks, it is a significant, this significance risks or critical risks come to the tolerable or normal risk zone. You have to go this all the hazard you have taken, you have to calculating the risk, then risk control measures, and after that residue risk assessment. It is electrical, one example of electrical department, cement industry, electrical HIRA, it is shown. Okay. Thank you. Now come any question from your side. It is a cement industry based HIRA. If it is a chemical industry, if the process is changed, but overall the basic structure will be same. They are little different as per the process. You have to take the process, what activity we have taken, and as per the activity we have to take the hazard. Hazard is there, and every hazard we have to take risk categorization or risk matrix, and then actually there we have to take the exposure part. They are mainly two. One is the severity, and another is the frequency. We have multiplying severity with the this frequency part, or consequency with the this part, along with the exposure. How much exposure? If it is the chlorine, ammonia, there is a chance of high exposure. Okay, ultimate these two or these three we multiplying, and earlier I have seen, I have given this chart there, the 1, 2, 3, 4, 5 for the likelihood and consequences, or severity and the frequency. And which zone it is? If it is a red area zone, that is a very critical, and if yellow, it is a moderate, and if it is a green or a normal, uh, normal non-significance zone. Any question, please?
Participants may come forward with their questions or any queries, or they can post in the chat box.
Any industry, when you go there, you have to first assess the hazard. You clear. In this team who made the HERA, they are in this team, the departmental head, engineers will be there, but their team members, core team members will be, can be all the employees are there, because hazard mainly come out from the ground level person. So first, when we taken the hazard from the ground level, we have a meeting with them. That is a brainstorming session will be there with the department or departmental team members, with the team members. Brainstorming, and they give all the small types of activity and also hazard they have given. You have to taken care of for that. You don't tell it is a small hazard, why it is given you. No, you have to give importance all the hazard. Is it is small or big? You cannot. First, we have to identify more numbers of uh, more numbers of hazard come. That is better for your safety, health, environment system of the industry. That is my way.
Hello, Sanjeev.
Yes.
Sir.
Yes.
Thank you, Sanjeev.
Hello.
Yeah. Yes.
Thank you, Sanjeev. Thank you for your good presentation. I am really benefited. I am benefited much because practical experience we have done both. Thank you very much.
Thank you, sir. Maiti sir, with me. I not know. He is my Guruji in this
No,
field. He
no,
is
good.
very much.
Still learning. I'm still learner. Okay, okay. Nice presentation. Okay. So critical subject
Yes.
you have presented nicely. Okay.
Okay. Yes.
Thank
yes.
you.
Yes. It is a nice presentation. One question from my side, actually, RPN. What is actually risk priority number? How to calculate that RPN? Please discuss.
Okay. You can see here again. Actually, you can see here the critical. When we take the criticality, we calculation the risk, how much critical it is. So then we give the priority for that. Okay, their consequences, and also mainly three things are there. One is the how frequently it happened, the incident happened. Okay, and second is uh, how the severe it is, and third is the exposure level. If you this multiplying these three, you got the number. If it is say for 1, 2, 3, 4, 5, you got it is 2. Another is 3. 2 into 3 into exposure, it is 1, say for then 6 into 1. Okay, then we go for this structure, what I have given the consequences and likelihood. That type of, if it is in the 3 into 3, also we give the give in the connection with exposure, which region it is come. If it is red zone, it is a top priority or critical risk. If it is yellow, it is moderate, and if it is green, it is not so significant or tolerable risk.
Yes, yes, yes. Thank you. Actually, RPN may be actually of severity, occurrence, and detection or frequency. You can say
Yes, yes.
severity, occurrence, and detection.
Detection.
Okay, that is the formula. Okay, thank you. Nice presentation. Over to Aditi.
Now, participants, if you have any query, you can post or you can ask directly. Now, the session is open for interaction. You can clear your doubt, you can post your query. Please come forward, participants. So if, is there any question? If not, then I should proceed. Okay, then let's head on towards the end. That is, thank you so much for sharing your valuable experience with us. And participants have definitely enriched themselves with your cognitive knowledge. Now, on behalf of the Department of Chemical Engineering, I would like to facilitate you with a certificate of appreciation. For that, I'll be sharing my slide. Just a minute, give me some time. So there is a small token of appreciation for you. Thank you for sharing your experience with us.
Thank you. Thank you.
So that was the end of our technical session.
Another thing you can
Yes,
just
yes, continue.
Actually, when we made the HIRA, first time we made HIRA roughly, but every year it should be reviewed again and again, because the industry, for different reasons, it should be reviewed, because if you not reviewed properly, then it may be it may because these three portion, it may vary from the environment or safety different it should be reviewed by the top management. It is the calculation should be as per the environment or as per the hazard may changes as per the situation. So every year it should be reviewed properly. It is last year, the factory inspector, they asked me you have reviewed on-site emergency plan and HIRA. We say no sir, but they suggestion given to us, every year you should review your on-site emergency plan, HIRA and JSA every year. So that is my request to you when you are going for the industry. Think that one time you make the HIRA, it is not okay. You should review it properly every year. Thank you.
Okay, thank you once again, sir, for sharing your experience with us. Now, I would like to say that tomorrow is the last day of our 5-day online workshop, and tomorrow we are going to have with us invited speaker, Sri Amar Kumar Ganguly, that is retired Director Safety, Central Labour Institute, Government of India, Mumbai. We are going to have with us Sri Amar Kumar Ganguly, retired Director Safety, Central Labour Institute, Government of India, Mumbai, and he is going to discuss on process safety audit. And as it was pre-scheduled that tomorrow there will be a technical quiz session that is at 7 p.m. sharp. The technical quiz link will be shared in chat box, and participants will have to submit their response in that link within 7:20, and that is much mandatory to receive your certificate. So that was all for today's session. Thank you so much, everyone, for your kind cooperation. Thank you so much.
Thank you.
Thank you all.
Thank
Thank
you.
you. Good night.
Good night,
everyone.
everyone. Good night.
Thank you.
Okay, bye, Sanjeev.